Greetings, Mr. Sutton here, bringing you the AB Calculus 4-3 Extra Practice Number 4 solutions on local extrema. On this problem, we're given f prime, the derivative of some function, and we want to know which statement is true. So all of these statements are talking about how many relative mins and maxes the original function has. To figure that out, we need to look at the sign changes of the derivative. So we see here on this graph that f prime is changing from negative to positive in, let's see here, 1, 2 places. Therefore, that means that f has 2 local mins. All right, and we also notice that f prime is changing from positive to negative in, let's see here, no sign change, 1 spot. That 1 spot right there. Well, that means that f has 1 relative max. So looking at our answer choices, 2 relative mins, 1 relative max, that's going to be choice B. On this problem, we're told that f is an antiderivative of g, and g is defined here. We want to know where the x value is, that's the location of the local max for f of x. Well, if I want to know the local max for f of x, I need to know where f prime, the derivative of f, changes positive to negative. Well, what's f prime? They told us that f is the antiderivative of g. What that means, if you haven't seen antiderivatives yet, is that f is the function you need to take the derivative of in order to get g. Well, that means that f prime is g. So if I'm asking where f prime changes positive to negative, I'm really asking where does g change positive to negative? And that we're going to look up on the calculator now. So on my calculator, I've entered the g function, which is also the f prime function, as my y1 in the y equals, and I need to know what window I'm graphing this thing on. Looking at my answer choices, they all are clustered between -4 and on the right side here, +4. So let me go back to my calculator and let me go to window. I'll set -4 as the x min, +4 as the x max, and then let me do zoom 0, zoom fit, and let's see what this looks like on a graph. All right, so there we go. Now, I wanted to know where this changes positive to negative, and it looks like that happens right at this spot here. So let me do second trace and pick option 2 for zeros, and let's move my spider a little closer to that intersection. Press enter, and then move to the other side of it. Press enter again, press enter one more time, and we get about 3.14 and some change. Almost pi, really. So there was my graph. There was my value of x. And this means, since f prime is changing positive to negative there, that means that f has a local max at x equals 3.140. So therefore, choice D. For this one, we're given this f function whose first derivative is as follows here, and we want to know where f has a relative max. So basically, I'm asking where f prime changes positive to negative, and to know that, I need to find critical values and do a little sign analysis. So, critical values, if I set f prime of x equal to 0, that's going to be at 0, 5, and -1. And we're going to do a little f prime number line here to analyze all this. So we've got -1, I've got 0, I've got 5. And let me plug in some numbers from each of these intervals to see whether they come out positive or negative. So to the left of -1, like -2, plugging that in here, we've got a negative. This squared term is automatically going to be positive, so I'm just going to ignore it from now on because it doesn't really change anything. And then we have a negative over here, so we have a negative times a negative giving me a positive. And then between -1 and 0, we can try out -1/2. So that's going to give us a negative times a positive, which comes out negative. Between 0 and 5, let's try out 1. That's going to give us a positive and a positive, actually, so positive there. And after 5, like 6, that's still going to give us a positive times a positive, so positive overall. Now, I notice that I'm changing from positive to negative at x equals -1. F prime is changing sign like that. So that means that f itself has a relative max at x equals -1, which is going to give us answer choice A. For this problem, we have the temperature inside a vehicle modeled by the F function in degrees Fahrenheit, and T is measured in minutes. We don't know what F looks like, but we know the first derivative of F is given by this F prime of T function right here. Looks like a combination between a quadratic and some kind of trig function. So we want to know at what time between 0 and 4 our temperature attains a local min. Okay, so that means I'm asking, when does F prime change from negative to positive? And to look that up, I am going to need the calculator. So here I am in the y equals of my calculator. This is F prime of T, basically. I just entered it in y1. And in order to graph this thing, I'm going to graph it between 0 and 4 for the window, because that's the time interval they gave me. So let me go to window, and I've got 0 to 4 entered in there already. Let me do zoom 0, zoom fit. So here's our F prime being graphed out. Now remember, we're looking for a change from negative to positive. So looking back here, there's only one place that happens, and that's this spot right here. So let me do second trace, options 2 for 0. And let me move my little spider closer to that intersection. There he is. Press enter once to the left, enter once to the right, and enter one more time. Comes out to about 3.299. So because F prime changes negative to positive at about that time, that means that F has a local min at 3.299 minutes, which is going to give us answer choice C. On this problem, I'm given the polynomial right here, the f of x function. I want to know where this thing has a local min, at what x value. So to figure that out, I need to figure out where the derivative, f prime, is changing from negative to positive. So let me find f prime and get some critical values. F prime, using the power rule, is going to be 3x squared minus 6x minus 9. And we're going to set that equal to 0 and solve. I can factor a 3 out of all this, so that's going to be x squared minus 2x minus 3 equals 0. And factoring this, I need numbers that multiply to negative 3 and add up to negative 2. So I can write x plus 1 and x minus 3. So that gives me x values negative 1 and positive 3. So these are my critical values. I'm going to put these on an f prime number line and do a little sign analysis now. So there's negative 1, there's 3, and here we go with some sign analysis. So to begin this, let me pick a number to the left of negative 1, like negative 2, and I'm going to use the factored version of f prime right here. So that's going to give me a negative times another negative, which is positive if I plug in negative 2 for x, and then a number between negative 1 and 0, or 3 rather, let's pick 0. That's a positive times a negative if I plug that in, so that's a negative. And then bigger than 3, let's go with 4. So that's a positive times a positive, which is positive. Now I wanted a local min, and I notice here that f prime is changing from negative to positive at x equals 3. Therefore, f has a local min at x equals 3. So that's going to be answer choice, here it is, A. On this real-life problem, they're telling us the concentration of a certain element in the water supply of a town is modeled by F, which they're not going to tell us too much about other than it's measured in parts per billion and T is measured in years. But they did tell us F prime is given by this weird logarithmic trigonometric function. Yeah, this is a calculator problem. If you were wondering, look at the answer choices. At what times T, between 0 and 5, that's important, does the concentration attain a local min? Okay, so I'm basically asking, where does this f prime that they gave me change from negative to positive? So f prime changes from negative to positive at some place that we're going to figure out by looking at our graphing calculator. Here I am in my y equals for my calculator. I've plugged in the f prime of t function in there, but I still need to know where to graph it. So looking back at the problem here, it looks like 0 to 5 is the window I should use. So going to my calculator, I'm going to go to window, and I'll do 0 to 5 for my x min and x max. And then I'll do, let's see here, zoom 0, zoom fit, and that'll give me the perfect window, at least what they wanted me to see for this function. Now we're looking for negative to positive change. That happens right about here. So let me do second trace, option 2 for 0. Let me move my spider a little closer there. Press enter, move a little bit to the right. Press enter again, press enter a third time, and we end up with a time of about 3.353. So there was my graph, there was my time. And since we're changing negative to positive for f prime at that spot, this means that f itself attains a local min at 3.353 years, which gives us answer choice C. On this problem, I'm given the derivative of a function, f of x here, and I want to know where the original function f has a relative max. So I'm basically asking, where does f prime change positive to negative? For that, I'm going to have to get critical values and do some sign analysis. So f prime of x, represented here, let's say that that equals 0 at the following values. So that's going to be at x equals negative 1, positive 2, and positive 3, whatever zeroes out these parentheses. So let me set up an f prime number line and put those on as my critical values. I've got negative 1, 2, and 3. And now let's test a number in each of these intervals. So to the left of negative 1, let's use negative 2. That's going to give me a negative times another negative. 3 negatives is a negative. Now between negative 1 and 2, let's use 0. That's going to give me a positive, a negative, and a negative. 2 negatives is a positive. Between 2 and 3, let's use 2.5 or 5 halves. That's going to give me a positive, positive, and a negative. 1 negative is a negative. And greater than 3, let's use 4. That's going to give me 3 positives, which is a positive. So I notice here that I'm changing from positive to negative at x equals 2 only. Therefore, f has a relative max only at x equals 2. So that's going to be choice A. For this problem, I'm given the graph of f prime, and I want to know which of the statements about f is true. Now, all of these have to do with how many relative mins and maxes the f function has. So we basically need to figure out how many times f prime is changing negative to positive or positive to negative. Now, looking at the graph, I notice f prime changes from negative to positive in, let's see, one spot, just this one spot. That means that f has only one relative min. Now, f prime changes positive to negative in, let's see, 2 spots. So that means that f has 2 relative maxes. 1 relative min, 2 relative maxes. That's going to be choice A.